This is a more difficult implicit differentiation question. So it says the equation of the curve is 15y cubed plus xy plus 8 root x is equal to 0. Find the gradient of the curve at each point where y is equal to minus 1. Right, so we've got 15y cubed plus xy plus 8 root x is equal to 0. So finding the x-coordinates where y is equal to minus 1 means we need to substitute minus 1 into this. So we're going to get 15 times minus 1 cubed plus x times minus 1 plus 8 root x is equal to 0. So be very careful with negative signs. That's going to give you minus 15 because minus 1 cubed is minus 1 minus x plus 8 root x. Now in order to make this positive, I'm going to make this x minus 8 root x plus 15 is equal to 0. Now this is what's known as a disguised quadratic. So if I let p be equal to square root of x, the middle term here, the equation will become p squared minus 8p plus 15 is equal to 0. And you can see that's a quadratic. And this is what's known as a disguised quadratic. This factorizes quite nicely. The factors are going to be minus 3 and minus 5. And then solving it, we're going to get p is equal to 3. That means because p was root x is equal to 3. Therefore, x is equal to 9. Here we're going to get p is equal to 5. That means that root x is equal to 5. X is equal to 25. We need to now find the gradient at 9 minus 1 and 25 minus 1. So this means that we're going to have to differentiate 15y cubed plus xy plus 8. Notice I've now written this as, instead of root x, as x to the power 1/2 is equal to 0. So we differentiate implicitly. It's implicit because we haven't got like y is equal to or x is equal to. So using implicit differentiation, we're going to have d dy of 15y cubed plus d dx of x times y plus d dx of 8x to the power of 1/2 plus d dx of 0. So you need to differentiate every term, including the last one on the other side of the equation. Right, you can't differentiate this with respect to x, but you can. It will become 45y squared times dy by dx. This one here, we will have to use the product rule because we've got x times y. So u is x, v is y. So it's going to be u, which is x, times the derivative of y with respect to x, which is dy by dx, plus v, which is y, times the derivative of x with respect to x, which is 1. This will become 1/2 times 8, which is 4x, and then reduce the power by 1, we get minus 1/2. And if you differentiate 0, you're going to get 0 again. Okay, so we've got two things here with dy by dx on. So we'll write them here, and we'll take the other two to the other side. So it's going to be minus y minus 4 over root x. Now, it'd be good to put this over a common denominator. So just leave this as it is, but taking out the common factor of dy by dx, so we get 45y squared plus x, and then we get dy by dx here. And then what I'm going to do is I'm going to write this as minus root x times y minus 4 all over root x. So just put this over a common denominator of root x. Right, now I can divide by this. So get dy by dx is going to be, now taking out the minus sign here, we'll make this root xy plus 4. But the minus sign goes in front of the line because the line here acts as a bracket. And then here we get root x times 45y squared plus x. Right, we've now got our values, so we can now substitute in. However, it might be easier in this case to substitute in here the values of x is equal to 9, y is equal to minus 1, or 25 minus 1 into this. It might be easier to deal with. But in a question, you might be asked to rearrange the defined dy by dx. So this is why I've included both. Right, so I'm now going to substitute 9 minus 1, 25 minus 1 into this. So I've got dy by dx is minus square root of y plus 4 all divided by root x, 45y squared plus x. at 9 minus 1, dy by dx will be root 9 times minus 1 plus 4 over root 9 times 45 times minus 1 squared plus 9. So that's going to give me, right, so that will give me 3 times minus 1, which is minus 3, plus 4. Here we're going to get 45 minus 1 squared is positive, so it's 45 plus 9. So that's going to give me 1 over 3 times 45 plus 9 is 54. So that gives me a gradient of minus 1 over 162. At 25 minus 1, we're going to get dy by dx is going to be minus root 25 minus 1 plus 4 over root 25 times 45 minus 1 squared plus 25. So that's going to give minus 5, because root of 25 times minus 1 gives me minus 5 plus 4. 5 times 45, because minus 1 squared is positive, plus 25. Right, so we're going to get minus 1 from here. We've still got that minus sign out here. And we're going to have 5 times 70. Minus 1 will give me plus, so we're going to get 1 over 350. Okay, so this has been a video to show you how to solve differentiate an implicit function, find its gradient at a particular point, and then also to find the corresponding x coordinates using a disguised quadratic. Now, it's quite an involved question, but I hope you've understood, and I thank you very much for watching.